In this lesson, we'll be using the derivative to find maximum and minimum values for polynomial functions. We'll begin today with an example. In this example, we're asked to find the extreme values for the function f of x equals x cubed minus 3x squared minus 24x plus 5. To do that, let's begin by considering what the graph of this polynomial function might look like. Without picking up a calculator, we know that a third-degree polynomial could look something like this. And if it does have this type of shape, we know that it could have an extreme value. Here, we call that a relative maximum, or here, we call that a relative minimum. And again, the word relative is used in these instances because there are points that are higher than this one, and there are points to the left that are lower than this one. They're called relative because they're relatively high within the area around them, or relative to the points around them. This is low relative to the points around it. Now, it could also look like this, in which case it would have no extreme values. It could look something like this, in which case it may have a plateau. But we're going to be able to figure out algebraically which of these cases it has. And to do that, let's consider this case. If this does in fact have a maximum and minimum value, let's think for a second about what the tangent line would look like at those points. A tangent line touches the curve. In this instance, it would look like this. Over here, it would look just like this. So if we have a tangent line at those 2 points, you can see that both of them are horizontal lines, which means that the slope is 0. Now, keyword slope here tells us something. Because we know how to find the slope of a curve, we use this thing called the derivative. And for today's lesson, we're going to use our shortcut rule for finding the derivative of this function. The shortcut rule we call the power rule says this. For a polynomial function, the derivative is the exponent 3 gets multiplied by the coefficient, which is a 1. 3 times 1 is 3. Then we decrease the exponent by 1. That becomes x to the second power. The next term would be exponent 2 times negative 3, which is negative 6. Decrease the power by 1. That would become x to the first power. The next one has an exponent of 1. 1 times negative 24 is negative 24. Decrease the power by 1, and we get x to the 0 power, which is 1. Now, I won't be writing that. And the derivative of a constant is 0. So this is the slope of the tangent line. In this particular instant, we're thinking about this case over here where the slope is a horizontal line, or where the line is a horizontal line and the slope is 0. So what we're going to do to find these maximum values is we're going to go ahead and take this equation, 3x squared minus 6x minus 24, and we're going to go ahead and set that equal to 0 because the slope is 0 at the extreme values. Now I'm going to go ahead and solve this, and because it's quadratic, I would solve it either by factoring or by quadratic formula. In this case, I'm going to attempt to factor, recognizing a 3 common to each of those terms. So I'm going to factor that 3 out, giving me an x squared, a minus 2x, and a minus 8. And I believe that is going to factor, so let's go ahead and take care of that. That would be x minus 4. X plus 2, and based on these factors, we know we're going to have an x value of 4 and an x value of negative 2. I do know at this case that in this problem it is going to be this case where we do have one of each. To decide which one we have, the next thing that we're going to do is we're going to find the function's value at each of these x values. So we're going to go ahead and evaluate f of 4, and we're going to evaluate f of negative 2 to see what we get. So let's go ahead and plug that 4 in into the original equation to figure out how high it goes at that point. So in the original equation, that's 4 to the third minus 3 times 4 to the second minus 24 times 4 plus 5. Go ahead and give yourself a second and do the evaluation. When I do it, I get negative 75. Go ahead and pause and see if that's the same thing that you get. With the similar reasoning, we can plug in a negative 2, and when I do that, I get a 33. Now, one of these points is a maximum and one of them is a minimum, and we can easily tell which is which by looking at the y values. This one's quite a bit lower. That's going to be our minimum value. Big number, that's going to be our max. So we're going to say here that we have a relative max of 33 at x equals negative 2, and a relative min of negative 75 at x equals 4.